Hey guys, and welcome back to how to make elements from household materials. Now today's element is hopefully going to be platinum. So platinum is used inside of catalytic converters such as the one in front of me here. Now this is just a really old car, as you can see, and so I'm going to be trying to extract platinum from this. The problem is it's stuck in the car. Now only cars made after about 1974 contain catalytic converters. That's when it became mandatory. So you're going to find these. There's the muffler down there, so before the muffler, but after the engine. That's typically where they're found. So here's our catalytic converter, and the stuff should be inside of this mesh here. So what I'm going to be trying to do is, since this is so rusted that we're never going to remove these bolts, I'm just going to try to dissolve this off with hydrochloric acid. So there's a couple different connections that we'll need to dissolve off, but I'm going to try to do that. And I'll meet you back as soon as I get this thing out of the car. Well, that took quite a while. The hydrochloric acid, I should have known, wouldn't work because it just doesn't dissolve steel nearly fast enough to do anything. So, of course, I had to pry that thing open, and it was extremely difficult to pry open. It took a whole lot of time to pry open. I was able to get some of the stuff out on the inside, and it wasn't a light, fluffy thing like I thought it would be. Instead, it was actually this kind of hard brick-like stuff with a bunch of holes that go through it, which is where the exhaust would have gone through and been catalyzed and broken down into more safer gases. So, we actually have to powderize this first before we can really do anything with that. Breaking it with a hammer could easily make us form all the dust, which would be going away, and we'd be losing our valuables, which is very undesirable. So instead we're going to be trying to use this ball mill. Now this is very hard stuff, and I really don't know if this will work. I'm just hoping it will. So I'm going to transfer all of this into the ball mill and crush it up we'll leave it in there for like 2 weeks and check on it every now and then just to see how it's doing. Hopefully it breaks it up into a fairly fine powder, or at least a coarse sand-like material, which will be much easier to work with. So I'll meet you back when I've done all of that. So I only crushed up half of the catalytic converter parts because that's all I could fit in my ball mill. And I crushed it up for about a week, just letting it tumble around with some marbles in there. And I'm going to check on it now. And it most likely is done. Now, so first we'll open this. And I did check it on it earlier in the week, and it was rather interesting because, and probably, yeah, it's still the same. You can see that there's all this goop on here. Now, the only reason I could think of is that because that catalytic converter was outside for so long, it, of course, had a lot of water in it. And this caused it to form paste rather than a simple, powder, which is what we were desiring. But this isn't too bad, because we should be able to fix this. Now, I can still see there's a couple of chunks, but I want to get out as much of this as possible, because it's having a bit of a difficult time. I could hear it, because now that it's all pasty, yeah, all the marbles are stuck on the edges. Anyhow, so what we're going to do is wash each individual marble with the spray bottle, or squirt bottle or something, into this beaker, and put the marbles aside, and do the same thing with the lid and the ball mill, and just get all of that palladium and platinum and rhodium containing stuff into this beaker. Doesn't matter how much water you use, but basically we just have to keep doing this until we've gotten rid of all of that. Then we can boil down our solution so that we're left with the pure kind of cake type stuff, which can be easily ground up. And any of the larger pieces can just be put aside. So I'll do that and meet you back. So we got everything out of our ball mill over here, and got it into the water. We simply boiled down our solution of water until it was, all the water was gone, and it was a nice, hard, dry substance. At this point, we broke off everything from the beaker, transferred it to this magic bullet here, and crushed it up into a really fine powder. Then repeated the exact same step in the ball mill with the rest of the catalytic converter pieces until that too was in a fine powder, and the similar process was repeated. So you're now left with a very fine, nice, platinum-containing ore, I guess you could say, in this nice, fine, powdery state here. And we do have quite a bit of it. Now, we're going to use aqua regia, which is a mixture of nitric acid and hydrochloric acid, in the ratio of 3 parts hydrochloric to 1 part nitric acid, and that will dissolve our platinum, and we'll have to heat it up to do so. However, the bad thing about this is that we're going to need a lot of it for this amount of ore. Or, well, we'll call it ore, I guess, because it contains platinum. And we don't want to use a whole lot because it's actually rather expensive to get the nitric acid, although I do make it myself. And I do show how to do that in a previous video. So instead what we're going to do is get rid of as much of this stuff as possible first. and this can simply be done through incineration. If we heat this up really hot, then we could drive off any of the hydrocarbons or sulfur or any other organic compounds which will hopefully break down. At this point, we'll have reduced the volume a large amount, so we will have a more concentrated platinum ore, and we won't have to use as much of the aqua regia to dissolve everything. So this will just help us out. So what we now have to do is go ahead and heat this up really hot. So I'll probably use some sort of iron crucible or something, and then a blowtorch, and just torch this thing to death. First of all, I'm going to actually weigh how much we have, so we can do a comparison after we've torched it and see how much we actually burnt off. So I'll set that up and meet you back. Okay, so I quickly made it. I just wanted to put the number here. I have 433 grams. So nearly a pound of this powder here. So I'll go get ready a steel crucible on our incineration unit. Okay, so we're now outside, and I have all 433 grams of our platinum stuff here. Now, first, of course, we have to incinerate it, as I mentioned before. So I'm just using this old baking pan, which is strictly dedicated to science, and this camping stove. So we can now begin to add our powder to this very hot surface. And this should hopefully decompose everything. Now, platinum is a very high boiling point of over 1,700 degrees Celsius. I believe that's just its melting point. Anyhow, so we're definitely not going to be boiling away any valuable platinum here, or rhodium, or palladium. We're just going to be reducing any of the stuff which can be reduced. So we'll just be heating this really hot, constantly stirring, and we should notice just some smoke that will start to eventually come off as it gets hot enough. And this is just any unburnt hydrocarbons and sulfur burning off. So we'll do all of that, and then I'll meet you back as soon as it seems to have stopped smoking. So actually, not a huge amount of smoking occurred, but I weighed it out after, and we're actually only left with 373 grams, which I just wrote down below. And this means that we lost approximately 60 grams of our mass in gases which were converted and burnt off. And that's actually quite a bit. Although there didn't seem like a lot of smoking occurred, there was actually quite a bit of gas that clearly came off. So the step to incinerate is definitely worth it, because we do lose quite a bit of our mass. So now we must start to prepare the acidic solutions. So in a previous video I showed you exactly how to make nitric acid, concentrated nitric acid, from household materials, and this is one of the ingredients we'll need, and the other ingredient is hydrochloric acid, which I will get out in a moment. And this is just sold as muriatic acid at places such as Home Depot or Canadian Tire. Anyhow, so the mixture that we're going to be creating is 3 parts hydrochloric acid to 1 part nitric acid, and then we'll add a bunch of water because we want because we're not going to end up using a huge amount because there's barely any platinum in solution, and if we dilute it, it'll just make sure that everything is covered by it. Now, at this rate, with all of that what is called aqua regia, that mixture of hydrochloric and nitric acids, it will actually very slowly dissolve the platinum, and palladium, of course. What we really need to do is heat this up. So I am going to be transferring it to a beaker in a moment. But the other thing to note is that upon heating this up, it will actually not dissolve any of the rhenium which is in here. So, after we get everything into solution, all our platinum and palladium, we'll actually be left with a beautiful rhenium ore, which contains pretty much pure rhenium. And I do plan on trying to get this out in a separate video, but rhenium is actually very difficult to extract from anything, and there's barely any in here. I'm mainly after the platinum and possibly the palladium. Anyhow, so I'll get the acid mixture ready and show you exactly how to do it in just a moment. So I found that a 500 milliliter beaker was sufficient to hold all that I have, although you may need a larger one depending on how much you have. So there's just under 400 milliliters of our powder here, and so I'm probably going to be using about 500 milliliters of our aqua regia. This will totally cover everything. We'll also place a large round bottom flask or some other glass object on top, filled with some water to help condense any of the vapors to keep them from boiling off, as we heat our solution so that all the platinum will dissolve. So we've come up with this amount here. Now this is an extreme excess because, of course, we just want to make sure that we dissolve everything. So basically 3 parts hydrochloric acid, 1 part nitric acid, and 4 parts water, I was thinking. That will give us 500 milliliters if we use 400 milliliters of water. 75 milliliters of hydrochloric acid, which is the muriatic acid, which is 32% concentration about, and then 25 milliliters of concentrated nitric acid, which is 68%. However, I prefer to use the higher concentration 90% stuff, which I make it by myself. This could be diluted, although I'll just use this straight up, so I'm going to be using about 20 milliliters of that. Although it's not very common to find, and it must be prepared by yourself normally, and the much more common type is 68%, because this stuff is just way too reactive. And if you don't believe me, check out my video of what it does to lab-grade gloves. Anyhow, all of that said, I'm going to take these all these acids and stuff outside and the beaker so we can begin the dissolution of everything. And I'll show you exactly how we're going to add the acids. Remember to always add acid to water and never water to acid, as it could cause vigorous boiling. Although this has never occurred with me, it could splatter acid all over you and severely injure you. It's just a good lab practice to do. So I'll meet you outside. Okay, so I bet you guys were thinking I was pretty dumb. There's no way 400 milliliters of water was going to fit in there on top of all that material. And that was not my intent at all. I just wanted to fill it up to 400 milliliters so that we could get a fairly good particle suspension so that everything would react. So rather than adding 400 milliliters of water, I just topped it up to the 400 milliliter mark on the beaker. Not sure how much water this was, but just up to the 400 milliliter mark, depending on however much powder you have. So the next thing that must be done is to prepare our aqua regia solution. So we can start by grabbing some hydrochloric acid, so it's muriatic acid, and yeah, so we'll take some of this, and we should measure out approximately 75 mils or so. So I just have my larger funnel here because, wow, that was pretty accurate. Because we don't want to accidentally spill everything. Now, plastics are rapidly eaten away by other acids, well, not other acids, but mainly just concentrated nitric acid. You could get away with a normal plastic funnel like this if you're using normal lab-grade 68% nitric acid, but because I'm using this highly concentrated 90% that we prepared separately in a previous video, we need to use a nice glass funnel. So, I'll add in the glass funnel, and now we must slowly add in enough nitric acid to top it up to the 95 milliliter mark. Top it up to the 100 milliliter mark if, of course, you're using lab grade stuff. And as you can see, a very vigorous reaction occurs. Anyhow, that should be about enough of this concentrated stuff, so put that aside. And you can see it's now slightly orange. So this can all be added to our beaker here, and then I'll set it up on our hot plate, and I'll meet you back in a moment. What I really meant to do but actually didn't, and this was a huge safety hazard, was remove my gloves. If you're ever dealing with nitric acid above 85% concentration, don't wear gloves. In a previous video I showed what happens when you put highly concentrated nitric acid on gloves, and a vigorous reaction occurs, and they burst into flames. I was meaning to remove them, but I forgot to. This is horrible lab practice. Definitely don't do this. I'm very lucky I didn't spill any of that concentrated nitric acid on myself. Anyhow, so I'll set this up. So as you can see, I simply set up this nice 500 milliliter round bottom flask on the top, and we have our beaker of stuff on the bottom. And I can see a slight reddish color happening, as we're actually starting to dissolve some of the platinum and palladium. Anyhow, so this is a good sign, but of course we haven't turned on the heat, so barely any is dissolved. Now this nice water bath type thing above here is just to help condense all the vapors so we're not losing all of our aqua regia. So we can now gently turn on the heating to the point where a gentle simmer is happening. This will hopefully keep most of the particles in suspension, while also heating the solution enough so that everything hopefully dissolves. And this round bottom flask with water on top should help keep all the vapors down so that we're not losing all our product. And I just have it clamped on top up here so it doesn't roll over. Anyhow, so we'll begin to turn this on and let it gently reflux for approximately probably 3 or 4 hours to make sure everything's dissolved. After that we can turn off the heat and I'll meet you back. So I actually let this thing reflux for about just under 24 hours. So a lot longer than originally described. And I was just adding a bit of nitric acid, maybe 5 milliliters or so every 10 hours. So I just did 2 additions of 5 milliliters of nitric acid just to give it a boost because there's a side reaction happening which forms other gases and actually destroys our aqua regia. Anyhow, so now that that's been done, we can, of course, I'll just lift this up a bit. We can take out a nice beaker, which is now cooled down, and hopefully contains lots of our solution. And over here, I've just set up a jar with a filter on it. And we will be filtering this into here. So, yeah, basically I'm going to quickly filter, and then take all the rest of the contents and put it into here, and do several water washings to get rid of as much as possible. And then I'm going to meet you back. Okay, so we had a bit of an issue. After filtering, there was a suspension of particles which came through, even though I used a very fine filter after using a coffee filter. And this is most likely just because we had such fine particles that through filtration, they just couldn't be separated. So, I had to let this solution sit for about 2 weeks, and it took a long time, and finally it had cleared up and everything had settled down to the bottom. And I decanted it off. There's still a bit outside that's still settling out, but here in that jar over there and there is the majority of the nice clear solution. And I did wash the stuff which we filtered off in the filter. I did wash that a bit with some water. That's just over there in that jar, and you can see it is also yellow, but it is not settling out nearly as fast, and there's still a lot of really fine particles. We can't use it till it's all settled out. So a very similar process will be done with that as to this. But we're just going to have to let that settle out for probably a couple months because it's just going to take forever. And realistically, there's not very much platinum or palladium in it. Anyhow, so I took some of this and transferred it to a small beaker, and we're just going to simmer it down. Now, the reason I chose to use a small beaker opposed to a larger beaker is because we can more carefully monitor this, the level of the solution with a smaller beaker. Because when boiling this down, if we get this too hot, the hexachloroplatinic acid will actually decompose into platinum 4 chloride. But because we have palladium in solution, this isn't okay, because we're going to end up ruining our final purity, because we'll have palladium and platinum in our final product. So you really have to make sure we do not boil this all the way down to complete dryness, and that we boil it down just till there's a bit of liquid left, then we let the rest evaporate off. And we'll just add the rest of this solution to this until we're just left with a little bit of liquid, probably about 10 or 20 milliliters or so. Not very much. Anyhow, so go ahead, start simmering it down, and I'll meet you back. Okay, so we boiled down our solution to pretty much complete dryness, let the rest evaporate off, made sure not to boil it all the way down to dryness or else we'd start decomposing stuff. And then after that, we just added about 20 milliliters or so of water to redissolve all of the hexachloroplatinic acid that was formed. And it was in solution, so we're just filtering that. And it's a nice deep red color, which means that we have platinum in solution. It's a strong indication. Now, just in case we did decompose a bit to platinum 4 chloride, we're just filtering it off. That will get rid of any of the insoluble impurities. And our total volume is around 40 or 50 milliliters now, because I did do several washing stages where I washed it all. But that shouldn't matter too much, because the main thing that we needed to do was get rid of all the acid, because we don't want very much acid when we do the next step, which is to turn this to ammonium hexachloroplatinate. And what we're going to need is some ammonium chloride solution. So it just dissolves about 2 grams of ammonium chloride in probably 10 or 20 milliliters of water. Doesn't really matter how much. But we made ammonium chloride in a separate video, and you can see it's right here. And it's pretty easy to make from household materials, ammonia, or ammonium hydroxide, and hydrochloric acid, which is sold as muriatic acid. So you could go see how to do that. And after this is done filtering, we can wash our filter quickly, and then remove that, and add our solution of ammonium chloride. This should precipitate out ammonium hexachloroplatinate, which is very insoluble in solution. And it's a nice yellow powder, which should hopefully fall to the bottom, which we can filter off, and recover the platinum from that. I'll show you how to do that in a moment. Okay, I just added in the solution, and something very interesting happened. So, as I added it in, this whole upper part became very clear. And the camera doesn't pick it up too well, but the bottom part is still much more cloudy. This is just because we haven't mixed around. But because it became clear, this strongly indicates that we actually did a chemical change, and we now have ammonium hexachloroplatinate, which has started to precipitate out. Because we've gone from our red-colored chloroplatinic acid to this more yellow colored ammonium hexachloroplatinate, and our solution has become much more clear, which is why we can see through it. So I'll go ahead and mix this around, and now we must let it settle out, probably overnight, so that we can get all of that very fine precipitant to settle down to the bottom. Hopefully we'll have a yellow precipitant in the morning. So I'll meet you back then. Okay, so I do believe that we actually have a precipitant of ammonium hexachloroplatinate at the bottom, because I let this settle overnight, and the camera might not pick it up, but yeah, you can see there's a layer of something down there. Not totally sure what it is. Should be ammonium hexachloroplatinate though. So we'll have to filter it off. And the remaining color in solution is either excess platinum, in which case we'll need to add more ammonium chloride, or we have palladium in solution, which we can recover later. Nonetheless, I'm going to be transferring everything into this separate container over here so we can store it until I'm going to extract other things out of it, most likely the palladium. So we can dump everything through the funnel, filter everything off, and wash out our graduated cylinder, and I will show you exactly what we have as that precipitant, and then I'll meet you back. If you look at the residue in the beaker, or graduated cylinder, I haven't rinsed everything out yet, but that is definitely ammonium hexachloroplatinate. It has a beautiful yellow color, so we'll rinse this out, transfer it to the filter, and I'm super excited. So we used about half of the solution, we still have the rest there. And there's a small amount of ammonium hexachloroplatinate which we obtained. This is super exciting. That means that we definitely got platinum out of that catalytic converter. This is amazing. I'm so excited. Anyhow, I also am going to actually put this back in the graduated cylinder, add more ammonium chloride solution to see if we can get anything else to precipitate out. And then I'll do the exact same procedure with that solution. And in a month or so, when that finally settles all the way out, I'll boil that down also and do a very similar procedure. And when I have all of our ammonium hexachloroplatinate transferred into this nice yellow powder, we will convert it back to platinum metal. And I'll do that in a moment. First, I'll set this out to dry and start processing the other solution. Okay, so it's been lots and lots of work, but I think we finally did it. You can see there's about half a gram of ammonium hexachloroplatinate in the bottom of this really small test tube, which I've just formed into the starting point of an ampule so we can seal it. Because what I'm going to do is, of course, decompose this to platinum metal, and this will be my element sample. Now, before we do that, I just wanted to discuss a couple things. One, we have not got all the platinum out of solution. And I verified this because ammonium hexachloroplatinate is actually rather soluble in water, 2 or 3 grams per 100 milliliters. However, in the presence of ammonium chloride, its solubility rapidly decreases. And in a 1 molar solution of ammonium chloride, its solubility is actually in the 10,000ths of a percent of a gram. So really small amount is practically insoluble. However, I don't believe we had our solution up to 1 molar of ammonium chloride, and I've actually run out of ammonium chloride. I do need to go make some more. But with the very last amount I had, I took all of our waste solution, which still contains palladium and definitely some platinum, as I just showed a moment ago, and I'll show you that in a moment. But so that's just basically all the what leftover waste that we used with our ammonium chloride solution. So what I did, I took a sample of that, boiled it down to concentrate it, but so that nothing precipitated out. Then took a 1 molar ammonium chloride solution, added it to it, and we have a very small amount of precipitant on the bottom. This is ammonium hexachloroplatinate, and due to its reduced volume or reduced concentration in solution and increased concentration of ammonium chloride, has precipitated out. This means we actually still have a fair amount more in here, so don't go straight to palladium recovery, which I will show in a separate video hopefully in the future. What we first have to do is take all of this, boil it down, and add a 1 molar ammonium chloride solution to it, and hopefully we'll get more of this ammonium hexachloroplatinate precipitating out. Maybe another 10th or 20th of a gram. So not very much, but it's still worth your time because platinum is so expensive. Anyhow, so now that we have this here, we can actually take this, heat the end up with a blowtorch till fully decomposes, and you'll just see a gray residue, which will be our platinum. Then, as soon as that's done, we can seal it. Don't seal it before heating it because the decomposition products of this are all gases except for platinum. And when it decomposes, those gases will cause your test tube to explode if you don't have this open so that it can vent out. So that's what it looks like on the inside there. So I'll get the blowtorch ready and meet you back. thought you guys might want to see it decomposing, so I'll just quickly do that here. So just take our sample and start to heat it up in the blowtorch. And pretty soon it's going to start decomposing. It decomposes at a rather low temperature. But we just don't want to crack our glass, because that would be really bad. Even though this is borosilicate, it probably won't crack. You never know, because that would be something quite bad if this were to fly everywhere. I can now see a color change. It's appearing to turn black. And yeah, I can see it's gassing off something. That's a good sign. And in larger quantities you should probably do this outside, but it should be okay here. And it does look like we have platinum metal that's being formed, so I'll finish this up and meet you back. So after that I simply heated up the middle of the ampule and sealed it off. And you can see that's what it looks like. We have a nice shiny platinum bottom there. And it's nice and clear at the top, which is nice, and it's sort of cloudy in between. And if we tilt this down this way, you can see there's all our beautiful platinum powder. And if you look at it under a brighter light than what's in my room here, and the camera doesn't pick it up very well, but it does have a slightly metallic look. Now, because this is an extremely fine powder, that's why it doesn't look like platinum, because it's in such a fine state. It almost looks like charcoal, but it is definitely platinum, and it's one of the highest purities of platinum you can get, because our method that we just used produces very, very pure platinum. If you wanted, you could take this and stick it in an arc furnace and melt it down, and but I just wanted to keep it as a powder. However, I have been extracting platinum from spark plugs, and I am making a video on that, and I do plan to melt that into a bead. I would just like to have a sample of powder and a sample of a little bead. Anyhow, so it's basically how to make platinum, but I want to see how much we actually got from that entire catalytic converter. So I'm going to take this to school. I have the top part of our ampule in this container here so we don't lose any of the pieces of it. And I have an identical test tube right here. So I'm going to go to school and use our super accurate scale, zero that test tube, add on our ampule here, plus the top part of the ampule, and whatever it weighs is exactly how much platinum we have. So, I'll go do that, and I'll meet you back when we have our results. Okay, so I'm going to be totally honest here. It's been almost a year since I started making this video, and I'm finally done. And I did complete the process of extracting the platinum a couple months back in November, and it's now the end of February. But I just haven't gotten around to getting this into school to weigh it. So got it into school, I weighed it. There is exactly 0.06 grams here. And then I expertly just dropped it a moment ago and cracked it. Thankfully nothing spilled out. It all stayed in the bottom, so I just epoxied it back together, which is fine. Thankfully it just cracked in a perfect circle, which was quite interesting. Anyhow, so this looks really nice. I mean, we have a nice amount of platinum powder here, 0.06 grams, worth approximately about $4. Not a huge amount, but it's also not worthless. I mean, that was pretty fun to do. Some other updates, since I finished this video, I built a fume hood. As you can see here, it has a nice bright light. And, yeah, that's really nice to have because it's a lot safer and I can now vent fumes outside. And yeah, that's basically how to make platinum from household materials, so I hope you guys enjoyed, and I'll see you in a future video. Bye.